Have you ever wondered how the sun's energy gets transformed into electricity through the magic of solar panels? It's a question that stirs the curiosity in many of us. Today, we'll be diving into the fascinating world of solar panels, more specifically, how they're manufactured. From the processing of silicon to the assembly and quality control, we'll walk through it all. So, if you've ever been intrigued by these shiny energy producers, now's your chance to learn. Well, buckle up, because we're about to demystify the process of making solar panels. Before diving into the manufacturing process, it's crucial to understand what solar panels are and how they work. So, in its simplest form, a solar panel is a device designed to absorb the sun's rays and convert them into electricity or heat. It's like a power station that's set up right on your roof or in your backyard. At the heart of these panels are solar cells, tiny powerhouses that do the heavy lifting. These cells are made from semiconducting materials, usually silicon, that soak up sunlight. As sunlight hits the cells, it excites the electrons in the semiconductor, creating an electric current. This process is known as the photovoltaic effect, and it's the key to turning sunlight into usable electricity. Solar panels are a marvel of modern technology, harnessing the power of the sun, a resource that's abundant, renewable, and free for everyone to use. Now that we've covered the basics, we're ready to explore the manufacturing process. The first step in making solar panels involves processing silicon. Silicon, a component abundantly found in sand, is the key ingredient for this solar symphony. But it's not as simple as scooping up sand from a beach. The journey of silicon starts in a high-temperature furnace, where it's heated until it melts into a molten state, transforming into a liquid that's hotter than lava. As intense as that sounds, the process doesn't stop there. This molten silicon is then meticulously cooled in a controlled environment. This is where the magic happens. As it cools, the silicon hardens and crystallizes, forming a large block, or what we in the industry like to call an ingot. But we're not quite done yet. This silicon ingot, as impressive as it may be, isn't quite ready for prime time. It needs to be sliced into thin sheets or wafers, the building blocks of our solar panels. And with that, we've completed the first step. With our silicon wafers ready, we can move on to the next step. The second step involves creating the actual solar cells from the silicon wafers. Now that we have our silicon wafers, it's time to transform them into functioning solar cells. This process is a fascinating blend of chemistry, physics, and engineering. The first part of this transformation involves coating the silicon wafers with a thin layer of metal. This metal coating serves as the conductor for the electric current generated by the solar cell. It's like the wiring in your house, but on a much smaller scale. The metal is applied through a process called screen printing, which ensures a consistent and even application across the entire wafer. But we're not done yet. The silicon wafers then undergo a process called doping, which is key to their ability to generate electricity. Doping involves introducing small amounts of other materials into the silicon. These materials alter the silicon's properties, turning it into a semiconductor, a material that can control the flow of electricity. There are two types of semiconductors created during the doping process, P-type and N-type. The P in P-type stands for positive, and the N in N-type stands for negative. These names refer to the charge of the particles that carry the electric current in the material. In a P-type semiconductor, the current is carried by positively charged holes, which are actually spaces in the atomic structure where an electron should be. In an N-type semiconductor, the current is carried by negatively charged electrons. When these two types of semiconductors come into contact, a fascinating thing happens. The electrons from the N-type semiconductor start to fill the holes in the P-type semiconductor. This creates a flow of electric current from the N-type to the P-type semiconductor. And voila, we have electricity. This process is the heart of every solar cell. It's what allows us to harness the power of the sun and convert it into usable electricity. It's a testament to human ingenuity and our ability to harness the natural world for our benefit. With our solar cells ready, we're halfway through the process. The third step involves assembling the solar cells into a solar panel. Now that we've processed our silicon and created our solar cells, it's time to put these pieces together into a fully functioning solar panel. This assembly process is a delicate, meticulous task. Our goal here is to create a panel that is efficient, durable, and capable of harnessing the sun's power to the fullest. Let's start with the arrangement of our solar cells. These cells are carefully positioned onto a panel in a specific pattern. The pattern is crucial as it maximizes the surface area exposed to the sun, thus increasing the amount of sunlight the panel can absorb. Once the cells are arranged, they need to be interconnected. This is done using thin strips of metal, commonly known as bus bars. These bus bars are soldered onto the cells, connecting them together in a series. This connection allows the electricity generated by each cell to flow from one to the next, creating a continuous electrical circuit. But it's not just about the cells and the metal wires. The panel itself plays a crucial role in protecting these components from the elements. After the cells are interconnected, the panel is coated with protective layers. Typically, a sheet of glass covers the front of the panel to shield the cells from weather conditions while still allowing sunlight to pass through. A layer of plastic, often ethylene vinyl acetate, is then applied to the back of the panel to provide additional protection and insulation. These protective layers serve a dual purpose. They safeguard the cells and wires from environmental damage, and they also help to trap the sun's heat, enhancing the overall efficiency of the panel. After these steps, the panel is sealed and framed, usually with an aluminum frame for added durability and ease of installation. The result is a robust, weather-resistant solar panel, ready to convert sunlight into usable electricity. With our solar panel assembled, we're almost done. We're one step closer to harnessing the power of the sun and transforming it into clean, renewable energy. But before we get there, we still have some testing and quality checks to conduct. Stay tuned for that in our next segment. The final step in the manufacturing process involves testing and quality control. Every solar panel that comes off the production line must go through rigorous testing to ensure it's working as it should. This involves everything from visual inspections to performance tests, checking that the panel is correctly converting sunlight into electricity. Quality control measures are also put into place to guarantee the longevity and efficiency of the panels. These measures include testing the panels under extreme conditions to make sure they can withstand the elements from scorching sun to freezing snow. They are also tested for durability, to ensure they can survive the test of time and continue to provide clean, renewable energy for years to come. Every panel is also checked for efficiency, making sure that it's converting as much sunlight into electricity as possible. This is crucial as it directly impacts the energy output and performance of the panel. And just like that, we have a fully functional solar panel ready to harness the power of the sun. So, that's the journey from raw silicon to a fully functional solar panel. It's a fascinating process, isn't it? We start with silicon processing, where the raw silicon is purified. Then we create the solar cells, where the magic of converting sunlight into electricity happens. The cells are then assembled into a solar panel, and finally, each panel undergoes rigorous testing and quality control. It's quite a marvel of modern engineering. Next time you see a solar panel, you'll know the hard work and precision that went into making it.